All right, this group we're going to do 11 through 20. So starting with number 11, we've got cosecant squared theta times tangent squared theta minus 1 equals tangent squared theta. All right, so I'm going to start on the left side, more complicated. I don't see any trig identities. You're not allowed to say that tangent squared minus 1 is something. I guess it's not anyway, is it? But there are no Pythagorean identities to start. So I'm going to begin by making this 1 over sine squared theta times tangent squared is sine squared theta over cosine squared theta minus 1. Changing to sines and cosines should allow you to cancel some things out. So sine squareds cancel. 1 over cosine squared is secant squared theta minus 1. And this is one of our rearranged Pythagorean identities solved for tangent squared x, or tangent squared theta. So that's it for number 11. For number 12, I see secant theta over cosine theta minus tangent theta over cotangent theta is supposed to equal 1. Now, normally I write everything in terms of sine and cosines, except I'm noticing that these fractions have their reciprocals together. So like secant over cosine, if I have secant times 1 over cosine, that's the same as secant times secant. So this is really secant squared theta. And same thing here. I don't normally change cotangent to 1 over tangent, but we have tangent theta times 1 over cotangent theta. So that's times tangent over 1. Or so that's, I'm sorry, divided by that. So sorry. So we have tangent times 1 over cotangent, which is the same as tangent times tangent. So this is minus tangent squared. And again, this is our Pythagorean identity. Originally, it's tangent squared plus 1 equals secant squared. If you solve that for 1, you get secant squared minus tangent squared. So this is equal to 1. We don't have to prove it any further. You're allowed to use the rearranged Pythagorean identities on our quiz. You don't have to prove that they're true. All right, for number 13, cosecant to the fourth theta minus cotangent to the fourth theta is supposed to equal cosecant squared theta plus cotangent squared theta. So which side is more complicated? I would say the one with a higher exponent. So I can begin by factoring. When you have exponents higher than 2, you should be factoring. If you're subtracting 2 powers of 4, you should be doing difference of squares. So cosecant squared theta plus cotangent squared theta times cosecant squared theta minus cotangent squared theta. One of those is a Pythagorean identity rearranged. All right, so what's the original we have? We have cotangent squared plus 1 equals cosecant squared. So cosecant squared minus cotangent squared is equal to 1. All right, now take a look at the right side. We have it, right? Cosecant squared plus cotangent squared times 1 is just cosecant squared theta plus cotangent squared theta. That's it for 13. For number 14, looks like we have something similar. So number 14 is secant to the fourth theta minus tangent to the fourth theta. We're supposed to show that that's equal to, scooched over a little bit, tangent squared theta plus secant squared theta. Okay, so again, let's start by factoring. It's a difference of squares. Secant squared theta plus tangent squared theta. And secant squared theta minus tangent squared theta. Just like we did before, you've got your Pythagorean identity that you know, tangent squared plus 1 equals secant squared. If you solve that or if you get that so that you get secant squared minus tangent squared, that's equal to 1. And there we have it. We're supposed to show this is equal to tangent squared plus secant squared, so I guess I'll rewrite the order that I wrote things. Technically, you're supposed to have the two sides match exactly, so I'll change the order of my answer. And that's it for 14. 15 is up next. So for 15, we have quantity 1 minus tangent theta squared is supposed to equal secant squared theta minus 2 tangent theta. Which side is more complicated? I don't know about more complicated, but I would think I could FOIL the left side versus starting to write in sines and cosines or something here. It might be hard to show that this, if I'm going from a non-parenthesis side to a parenthesis side, I'd have to show factoring of some sort, which I can do. Or I could just FOIL on this side. So I'm going to start on the left side and make this 1. When you FOIL a binomial, you get 1 minus 2 times tangent theta plus tangent squared theta. We've talked about this before. 1 plus tangent squared theta. Those two terms do not have to be next to each other because we can rearrange the order of these terms and get them next to each other. But 1 plus tangent squared is secant squared theta. So we have it, minus 2 tangent theta. That's the end of that. For number 16, we have 1 minus sine squared theta times 1 plus tangent squared theta equals 1. So remember, in general, I always like to look for Pythagorean identities if they exist. 1 minus sine squared is cosine squared theta, and 1 plus tangent squared is secant squared theta. And that's equal to 1 because cosine squared theta times 1 over cosine squared theta cancels out to 1. Okay, for number 17, we have cotangent theta over cosine theta plus secant theta over cotangent theta equals secant squared theta times cosecant theta. It's best to start on the side that has addition. There's more work to do there. I'm going to change to sines and cosines because I'm seeing a convenient setup, a mixture of sines and cosines here. Oops, so secant is 1 over cosine theta over cosine theta over sine theta. You could have started with a common denominator right away too, because these are going to multiply together nicely, but I think most of you will probably go this route. All right, so cosine over sine ends up getting multiplied, instead of divided by cosine, multiplied by 1 over cosine. And let's work on this one too. We always get rid of complex fractions. You can do that by multiplying by the reciprocal, like this. So cosines cancel. I've got 1 over sine theta plus sine theta. Nothing cancels in the second one over cosine squared theta. All right, so I'm getting pieces of this. I have a cosecant here, but then it's not times secant squared. So now that I'm adding fractions, let's get a common denominator. The common denominator is sine theta cosine squared theta. First fraction would have been multiplied by cosine squared. Second fraction would have been multiplied by sine to create a sine squared up there. Sine squared plus cosine squared is 1. 1 over sine is cosecant theta. I'll try to write this in the same order. This says secant squared. 1 over cosine squared is secant squared theta. And 1 over sine is cosecant theta. Since they're being multiplied, I can split this up like that. And that's the final for 17. For 18, 2 sine squared theta minus 1 is supposed to equal 1 minus 2 cosine squared theta. All right, order does not matter here. Which side is more difficult? Doesn't matter. I want to start on the right side so that you're aware of the negative to distribute through. So say I start on the right side. I've got only cosine squared over here, but I want to have sine squared. So let's make a substitution. We know that cosine squared is equal to 1 minus sine squared. And the reason I started on this side was just to point this out. When you distribute, make sure you're distributing a negative 2 through both parts. So you get 1 minus 2 plus 2 sine squared theta. It's very easy. I see this mistake a lot every year, all year, that negatives get dropped. So like sometimes people will have minus 2 sine squared. So just be careful of that. 1 minus 2 is negative 1, and I'm going to put the 2 sine squared first. 2 sine squared theta minus 1. Proof is done. All right, last two. Let's see if I can do this before I get cut off by the bell. So 19, secant theta minus tangent theta times sine theta equals cosine theta. So let's start on the left side and rewrite in terms of sine and cosine. These two fractions already have a common denominator, so merge them together. 1 minus, this is now sine squared theta. 1 minus sine squared theta is cosine squared theta over cosine theta, and that cancels or divides out to just cosine theta. And number 20, I think we're just going to make it here. 1 minus cosine squared theta times cotangent squared theta plus 1. If you know your Pythagorean identities, this is supposed to equal 1. This one's really fast if we know our Pythagorean identities. 1 minus cosine squared is sine squared theta. Cotangent squared plus 1 is cosecant squared theta. Sine squared times 1 over sine squared is equal to 1. All right, that finishes this section. Keep practicing. If you're good with these, go on to the next few. They get a little more difficult as we go.